Welcome to online lecture series in organic chemistry, and we are discussing the organometallic compounds. In this video I am going to start new group of organometallic compounds, that is metallosense. Now the organometallic compounds in which metal atom is in between planar polyheptoligands are generally called metallosense or sandwich compounds. For example, here you can see chromium, that is metal, it is sandwiched between two polyheptoligands. These are the benzene rings. Similarly, manganese, it is sandwiched between two rings. One is benzene ring, other is cyclopentadienyl ring. This is also one of the organometallic compound, and that is Metallosense. This is the third example. Iron, it is sandwiched between two polyheptoligands, that is cyclopentadienyl. So these are the metallosense. So Ferrocene is well-known metallocene. This is the Ferrocene, where iron is forming bond with two polyheptoligands, planar polyheptoligands, that is cyclopentadienyl, and this is the Ferrocene. Its IUPAC name is bis pentahepto cyclopentadienyl iron. So in this video actually we are going to focus on this Ferrocene. Ferrocene, this is the formula for Ferrocene, Fe pentahepto eta 5. Meaning of this is, it is this ligand, cyclopentadienyl ligand, it is pentahepto. So pentahepto cyclopentadienyl iron. Actually two cyclopentadienyl ligands are there, and therefore its name is bis pentahepto cyclopentadienyl iron, that is the Ferrocene. So this is the example of metallocene, where actually the metal atom, it is in between planar polyheptoligands. Now we are going to discuss the synthesis of Ferrocene. Now Ferrocene, it was synthesized, and it was the first metallocene, and which was discovered accidentally and independently by two different groups of scientists or workers, and the methods was by the oxidation of cyclopentadienyl Grignard reagent and by the direct reaction between iron and cyclopentadiene. Now first method we are going to discuss, that is by the oxidation of cyclopentadienyl Grignard reagent. Now in this method, the scientists Cayley and Pauson in 1981, these two scientists were trying to synthesize fulvalin by oxidation of cyclopentadienyl Grignard reagent, and actually the cyclopentadienyl Grignard reagent, when allowed to react with ferric chloride, they were expecting the formation of fulvalin, but surprisingly, instead of fulvalin, new product was obtained with dark orange color, and this product was later on named as a Ferrocene. So Ferrocene was accidentally prepared by Cayley and Pauson in 1981. So in this method actually the ferric iron salt was used for the oxidation, and this salt first of all reduced to ferrous iron salt, that is Fe2 plus, and for this reduction cyclopentadienyl Grignard reagent plays important role. So the cyclopentadienyl Grignard reagent reduces ferric salt to ferrous salt. Then this ferrous salt further reacts with Grignard reagent and there is a formation of ferrocene. We'll see the reaction. So ferrous salt, for example FeCl3, when allowed to react with cyclopentadienyl Grignard reagent, that is cyclopentadienyl magnesium halide, then first of all there is a formation of ferrous salt. This ferrous salt further reacts with Grignard reagent and we get the ferrocene, that is FeC5H5 twice, that is bis pentahepto cyclopentadienyl iron. Here there is a printing mistake, it should be C5H5 twice Fe. Okay, so here the reactions are, when ferric chloride comes in contact with cyclopentadienyl Grignard reagent, that is cyclopentadienyl magnesium bromide, then this ferric chloride gets converted into ferrous chloride. This is the first step. As soon as this ferrous chloride is formed, then this, in presence of ferrous chloride, the cyclopentadienyl magnesium bromide, it is converted into ferrocene, that is C5H5 twice Fe. So here in short we can say, first of all ferric ion gets converted into ferrous ion, and this ferrous ion combines with or reacts with cyclopentadienyl Grignard reagent and we get ferrocene. So this was the first method, that is the oxidation of cyclopentadienyl Grignard reagent. Now the second method, that is direct reaction between iron and cyclopentadiene. So ferrocene was independently discovered during the direct reaction between reduced iron and cyclopentadiene at 575 Kelvin in presence of suitable base. And in this method bases like amines, quaternary ammonium salts are used, and these salts are responsible to remove acidic hydrogen from the cyclopentadiene. For example, when this cyclopentadiene, this is the structure of cyclopentadiene, there are two hydrogens attached to this carbon. These are the acidic and these are easily removed by base, and therefore there is a requirement of base. So when cyclopentadiene is heated with iron at 575 Kelvin, then we get a ferrocene. There is an evolution of hydrogen gas. In this reaction actually this acidic hydrogen, it is removed by base, that is amines or quaternary ammonium salts. The exact mechanism of this reaction is, first of all, the iron when comes in contact with quaternary ammonium salt, this is the base, then there is a formation of ferrous chloride and tertiary amine, and there is evolution of hydrogen gas. So this iron, it is converted into ferrous salt. So there is oxidation of iron. Then this ferrous salt further reacts with cyclopentadiene in presence of tertiary amine, and there is a formation of ferrocene and quaternary ammonium salt. So this is the second step. These are the two steps, and the net reaction is the quaternary ammonium salts cancel to each other, 2 moles of quaternary ammonium salt. In one step it is consumed. In second step it is regenerated. Similarly, tertiary amine, 2 moles of tertiary amine gets cancelled, because in first step it is formed, 2 moles of tertiary amine is formed, whereas in second step it is consumed. And ferrous chloride is also cancelled. In first step it is formed, in second step it is consumed. So net reaction is iron reacts with 2 moles of cyclopentadiene in presence of amine at 575 Kelvin, and there is a formation of ferrocene and hydrogen. This is the net reaction, and this is the mechanism. For better yield, cyclopentadiene allowed to react with metallic sodium, and this is the metallic sodium, and cyclopentadiene allowed to react with metallic sodium. There is a formation of hydrogen gas, and one of the hydrogen of cyclopentadiene, it is replaced by sodium. So this NaC5H5 further reacts with ferrous chloride, and there is a formation of cyclopentadiene, bis pentaheptocyclopentadiene iron, that is the ferrocene and NaCl. So in this way, ferrocene, it is prepared by two methods. One is by the oxidation of cyclopentadienyl Grignard reagent, and second method, direct reaction between iron and cyclopentadiene. In this second method, most important thing is amines are used to remove the acidic hydrogen of cyclopentadiene.